Voxxed Days Vienna. I'm with James Weaver from Pivotal, and we've just given 2 talks about machine learning.
We have, yes. That was fun.
It was fun, actually. Yeah, I enjoyed it, and people seem to. I mean, blowing our own trumpet here, but people seem to appreciate it.
I think so. I think so. Yeah.
So one thing that we do is we go over 3 types of learning. So we go over supervised learning, where you have the correct answers and you have the data and you're saying, I'm going to give you all of the answers. Can you work out what's happening here? Unsupervised learning, where you go, I just have some data. Can you please find some patterns? Mm-hmm. And reinforcement learning, where actually, could you explain reinforcement learning?
Reinforcement learning is where you have an agent in some environment, and the agent has to learn something, has to learn to achieve some goal, and then is rewarded incrementally or maybe after it's achieved the goal with some type of reinforcement. And so that way it learns then to achieve that goal over a number of iterations.
So unfortunately we didn't quite have time to cover that in the talk, but reinforcement learning is the power behind the computer program that can beat the top AlphaGo champion.
Correct. That's one of the things, the forms of machine learning behind that. Other forms, it does use traditional supervised and some unsupervised learning, and so it kind of uses those 3 things together in a strategic way to beat the player. Yes.
So I'm not familiar with the game of AlphaGo, but I believe it's much more complicated than chess.
It's it's just called Go. The AlphaGo is the name of the project. Go is a 19 by 19 grid. I believe it was invented in China. And you put stones, there's black and white stones that you put on the intersections of the grid. 19 by 19 is 361, so there's 361 different places that you can place stones. And just an almost infinite number of combinations of board states. Orders of magnitude above what there is in chess, so yeah, much more complicated.
I can safely say that I've never tried to play that game. So when we were looking at some of the examples, something that we looked at quite a lot actually was neural networks, because they're so hot right now. Mm-hmm. And we finally have the computational power to do some really cool things with neural networks.
Yes.
So we looked at convolutional neural networks, handwriting prediction.
Yeah, for the general case of images, and convolutional, as you know, can be used for other things, but it really shines in being able to recognize what are in images, what's going on in them. As you mentioned, as we were preparing for the talk, as you kind of coached me, why don't you mention that it's the way that animals recognize things by recognizing features, so that the convolutional and pooling layers of that then kind of take features and recognize them much in the same way that we as humans do.
Well, we hope.
Yes, right. Yes.
One of the big problems with neural networks, especially the architectures of neural networks, and looking at, so as well as just a simple artificial network, you can have these recurrent neural networks. You have deep learning where you have multiple hidden layers and they can interact in different ways. And time series neural networks we're always kind of guessing at how the brain works. We're always guessing at how those neurons interact.
Yes.
I don't feel like I'm any closer the more I learn about machine learning to knowing that, but maybe any neuroscientists watching can step in and help us.
That's a good point. That's a good point. Yes, absolutely.
But what's your favorite thing to demonstrate about machine learning?
Oh, wow. That latest thing, it's always about the latest new toy, right? So the handwriting recognition thing, that was kind of fun, where you could take the digits, the handwriting samples of digits, and actually create one, write one, draw it out on this application, and then it shows you the different layers graphically, what's happening inside of the convolutional neural network, and then what classification it was given at 0 through 9. Yeah. That was kind of fun to demonstrate.
It is, actually, because I think especially when you're learning about neural networks for the first time, you might think, oh, handwriting recognition is really boring. But it's actually incredibly complicated. So the demonstration is a really good way to show how convolutional networks kind of compress what they take, the pixels they take in, and take different parts of that to work out how they all combine to make the digit 8,
Yes.
not 6.
Right, yeah.
Or a badly written 7 is a 7, not a 2 or a 1.
Yeah,
Or
yeah.
But yeah, that is really cool, actually. And there's a really good music duet program that you showed me in the break.
Yeah, that was an AI experiment related to Google Brain and Project Magenta, where we took a MIDI keyboard. It happened to be a Lindström, which is a very versatile MIDI keyboard, a very expressive one, and then played a short melody, kind of an improvisation kind of thing, where you play a little melody, a few notes, and then the recurrent neural network then predicts, plays, improvises, kind of using the recurrent neural network to predict what the next notes in the series should be based upon the body of work that it has been trained on.
I thought that was really cool.
It's kind of fun to jam.
Yeah. Oh, the keyboard itself is really cool, because it's not a keyboard in the kind of one key in a row sense. It's like a multi-dimensional keyboard.
It is. It's kind of a cross between playing a traditional keyboard and playing a guitar, because it's laid out in 8 rows of 25 keys, which allows you to slide and think in terms of how a guitar player would think. Yeah.
Cool. Well, for more, people have to check out the talks.
Absolutely. It was really great the way that I think it was a good interplay between discussing the kind of the theory behind machine learning and demonstrating code, and then also you diving into the intuition and the maths. I think it made a very kind of complete picture of peeking under the covers as far as learning what's going on, to where developers then, I believe, got a great intuition about what's going on underneath. Not that they have to, but when they're using machine learning libraries, it's not a mystery anymore. So
yeah, I hope so.
I think that was a good benefit to them.
And if anybody has any further questions, they can feel free to reach out to us on Twitter.
Absolutely.